Hello, my name is Peter Woodward. I'm Professor of High-Speed Rail, and today I'll be talking a little bit about the MSc in Geotechnical Engineering, which I'm the Programme Leader for. I thought we'd start perhaps by saying a little bit more about myself. As I mentioned, I'm Professor of High-Speed Rail on Geotechnics. My background is civil engineering and a PhD in soil dynamics. I'm a chartered civil engineer, a Fellow of the Institution of Civil Engineers, and a Fellow of the Permanent Way Institution. I held the UK Atkins Chair for High-Speed Rail. Between 2000 and 2010, I was a company technical director. I've published quite a lot of work, and I have a significant number of external awards, including Product Innovation of the Year. That was in track and ground reinforcement. My main research interests are geotechnics, particularly railway infrastructure and dynamics. My area at the moment is I'm very much interested in full-scale testing of geotechnical structures. So what is geotechnical engineering? Well, this figure here shows you the kind of rough areas that we can break them down into. Transportation engineering, looking at construction engineering, environmental engineering, earthquakes, and we have a couple of pictures to show you about earthquakes later, hydraulic engineering, then looking at materials, geology, and structural engineering. So what are some examples of geotechnics? Well, here is a couple of foundations, perhaps for bridges or buildings, abutments and concrete dams. We've all heard of the Leaning Tower of Pisa. That was actually a foundation issue, that there was a process of consolidation taking place over the years that it was constructed. Foundations for bridges, they could be on reinforced soil, they could be on bridge piers, concrete piers, and so on. We could be looking at dams, earth dams, particularly changes due to climate change. We have to start looking at how these earth dams start to respond as wet weather starts to increase. And there have been quite a few examples in the literature and in the news about failure of embankments and dams. The Toddbrook Reservoir was actually on the BBC in 2019. And what we're interested in is what's the flow of water through the dam? What are the seepage pressures? How does that cause instability on things like the downstream slope? How do you solve it? How do you design the clay cores, and so on? Other examples might include earthquakes. And in fact, my original research area and at my PhD level was on earthquakes, in particular earthquake-induced liquefaction. And if you don't know about these things, liquefaction is when you could have a sandy soil, for example, which is quite loose. And if an earthquake comes when the soil is saturated, you can develop a liquefaction. You get almost like quicksand, and this causes failure of the building into the foundation. Water can then, a lot of water comes to the surface, and then the stability of the building is affected as the foundations fail. It then actually starts to recover afterwards. So these are the types of things that we start to look at as geotechnical engineers. Tunnels, we've heard of, there's quite a lot of examples of tunnels around the world, and we can think of Gerrard's tunnel here, which was a classic failure when you have large pressures coming onto the tunnel. We can think of tunneling that's happened with the Channel Tunnel Rail Link in the UK, for example. So behavior of tunnels and pressures, that all forms in the realm of the geotechnical engineer. Another example, which is very topical at the moment, is slope instability. And landslides, what we would call translational failures, will start to become more common as climatic effects start to take hold. Particularly the increased rainfall might cause more and more landslides to occur. But of course, you can get traditional rotational failures, and that's a big part of geotechnical engineering as well. So what about our MSc in geotechnical engineering? The degree covers the practical application of geotechnical engineering to reduce construction risk and optimize the design of geotechnical structures. Understanding this risk is underlying philosophy of the geotechnical engineering course. And we bring together expertise to ensure that you'll have an understanding and skills to address the range of geotechnical problems, including shallow and deep foundations, soil structure interaction, ground as a source of energy, energy geotechnics, environmental geotechnics, slope and ground stabilization. So we cover a wide range of geotechnical issues and geotechnical designs. And I should say that the geotechnical engineers are highly sought after in the civil engineering industry. Geotechnical engineers integrate the skills of investigation, characterization, analysis, and design. You can think of a geotechnical engineer as often you don't have all of the data that you need. You do a lot of site investigation to try and determine the properties that allow you to do your design, but sometimes it's your engineering knowledge and your engineering expertise that allow you to actually develop the appropriate soil parameters to use in your design process. Obviously, you would have to think about design standards as well. Our modules to try and develop these skills include geotechnical investigation and characterization, pollution, contaminated land, geotechnical engineering, foundation engineering, energy geotechnics, constitutive models and numerical analysis, and transport infrastructure strategy. You'll also undertake a research project and an integrated design project. What about delivery? Well, the programs will primarily be taught face-to-face. Some content may be taught online. For example, it's normal to have a tutorial online. Some modules may involve a laboratory or computer modeling. Assessment is through the classic methods of coursework, individual and group activities, formative work, providing feedback as the module progresses, and summative work, which we would use in assessment processes. There are exams and, of course, the dissertation itself. What about the application process? Well, information about the application process, including the fees and the entry requirements, can be found by the link on the screen there. Information about funding opportunities can be found by the link underneath. And if you have any further questions, there is a contact email there which gets you through to the postgraduate office. So that's the end of this short talk. I hope that helps you in your decisions, and I look forward to seeing you at Leeds if you decide to come here. Thank you very much.